Okay, so now we're going to talk about two circles that are touching. Okay, so this can happen in two scenarios. So either like this, where the two circles touch externally, or like this, where the two circles touch internally. Okay, now if they touch externally, the way that you can decide which way they're touching is the distance between their centers is going to be equal to the two radii added together. Okay, so D is the distance between their centers, and D is equal to radius 1 plus radius 2. Okay, if they touch internally, the distance between their two centers is going to be the bigger radius minus the smaller radius. Okay, so your R1 is here, that's the big circle, and your R2 is here, and the distance between those two is R1 take R2. So show that the circles touch externally. Okay, so first of all you need to get the center and the radius. So the center is minus half that and minus half that, and the radius is, just stick that into your formula, 3 squared plus 2 squared, and then minus the c. Okay, so 9 and 4 take 11 is square root 2, and then the next center is minus half that and minus half that, and the radius is going to be minus 2 squared, minus 3 squared, and then minus c, so plus 19 here. And that's going to be 4 plus 9 plus 19 is root 32. And if you just throw that into the calculator, it's 4 root 2. Now, we're trying to show that they touch externally. So externally is the distance between their centers, these two added together. So first we need to find the distance. Okay, so the center, it's between these two. So it is x2 minus x1 to be squared plus y2 minus y1 to be squared. Minus 5 squared is 25, and minus 5 squared is 25. So that's square root 50. And if I throw square root 50 into my calculator, I get 5 root 2. Now for externally, it's D is equal to R1 plus R2. The distance is equal to root 2 plus 4 root 2. And from there you can see 5 root 2 is equal to root 2 plus 4 root 2 is 5 root 2. So therefore they touch externally. Okay, so just give your little conclusion there. And finally then we'll talk about chords and circles. So one property you'll remember is the perpendicular from a center of a chord bisects the chord. Okay, we'll just call this chords and circles. Okay, a circle, okay, has center 4, 2 and makes a chord 6 units in length on the y-axis. Okay, so it's telling us the length of the chord. Okay, find the equation of k. So obviously we're looking for the radius. Okay, now it's a circle. You know that it makes a chord 6 units in length. So I know that that distance there is 6 units. Okay, now we also know that the perpendicular from the center to the chord bisects the chord. Okay, so I know that this bit here would be 3 and this bit here would be 3 if the chord is 6. Okay, now the center is 4, 2. So this is 4, 2. So I know from here to here is 4. Okay, so that there is 4. Now I have a right angle triangle and I'm going to be able to find the radius. I know that bit there is 3. I know this is 4. Okay, because it's telling me it makes an intercept on the y-axis, I'm able to use the center to get that distance there. Okay, and then you can just do Pythagoras, but instead of doing Pythagoras, I know that that is just 5. Okay, and the center is x minus 4 to be squared, y minus 2 to be squared equals 5 squared. That will be your equation of the circle.